Hello everyone. Okay, we're back with the 42 KN6, and this time I have it hooked up in grid driven mode with negative voltage on the control grid, positive voltage on the screen, and we're still running about the same 550 volts on the plate. I have a Pi network on the input with two trimmer caps. They refer to these as pinch caps or compression caps because you tighten a screw and it squeezes plates, and the plates are separated by mica washers, and the tighter it goes, the more capacitance, and then as you relax it or unscrew that, the capacitance goes down. So they just refer to them as compression trimmers. Circuit is quite a bit more complicated. We've added a few things here. A second relay has been added to turn the screen off and on. I've added a high and low resistor divider network. That's these resistors here. There is a load resistor that takes part of the input tune load. It's a 440 ohm resistor. There's two 220 ohm resistors in series there, and that helps give a little bit of a continuous load as your voice on sideband and stuff will vary conditions. This keeps a pretty much even load on your radio at all times, and it improves modulation. And the tube is fed with a 0.01 cap that is a DC blocking cap. That's all it's in there for. And one end of our 24 volts negative is fed in through the 440 ohms. So that 440 ohm resistor is also serving as a network to provide bias to the control grid. Okay, now the big surprise is we have a whole lot more power on this one. Same tube, but instead of struggling to do 50 watts, this one tube does almost 150 watts. I have a very limited dummy load on this thing. I think it's probably flat out can only handle about 15 watts, so I can only key up for just a split second or so here. I gotta make sure my viewfinder can see. Okay, yeah, you can see the meter and everything. We have a SWR meter in the input circuit, and this is measuring from the radio going into the Pi network. This SWR was what the radio sees, and then of course our power meter is set to the 200 watt scale. Okay, we'll start out on low power, which should be about, I don't know, I think it's 20 watts or so. Alright, 35. SWR under 1.5. And I kick the switch. Now we're on high power. Almost 150 watts. And still about a 1 to 1.25, way under 1.5. Hello. Not a whole lot of swing. I don't have it peaked out. I don't have the time allowed on my dummy loads here. I can already smell them. they're getting hot. But on low, it does have pretty good swing. Hello, check. I could improve that quite a bit if I do some load and tuning on it, but you can see how close it is. I have this coil listed as 8 turns, but when I finally got it done, see if I can find my screwdriver here, I don't know if you can see this in the video, but right here I've had to put a little solder dot and short out one turn, because in tuning it I could not quite get the SWR all the way down, and in testing I had a flat match, but once I hooked it up to the tube, I didn't have enough range on my pinch caps, so I had to just remove one turn. So instead of 8 turns, and I will correct that on the schematic, it's going to be 7 turns at 3/8 inside diameter. And actually this coil was wound over, I believe it was in a AAA battery is what I used for the diameter, and I think it comes out right at 3/8 inch. So let me turn the power supplies off here, and I can point out different parts on here. Okay, as I said before, this is the high and low network. There are a couple of 10K resistors. There is a relay right here that I've paralleled across the antenna keying relay. It might help if I can keep that in the camera so you can see it. This relay I've added, and what it does, it turns the screen voltage on key up, and lets the tube shut off or go dormant on receive. The cap that you'll see across the contacts here is what is referred to as a arc quench capacitor. This keeps any kind of an arc that would want to stay going across these contacts when they open. There is a tendency to have a little bit of an arc on there at different voltage levels, different conditions. So to quench that, or to keep your contacts protected, it's just simply a 0.01 cap stops that nonsense. Okay, there is another switch has been added. This is a high-low. It allows me to select full power, my 200 volts, or the connection in between the two resistors, because one of the resistors is tied to ground. Then on top of it is the center point, and on the other end of the 10K is the full 200 volts. So I'm dropping 200 volts across 20K of resistance, and dead center of that is half of that voltage, so roughly 100 volts. So my screens are getting 100 volts on low power and giving me about 30-35 watts, as was seen there. On high, we give it the full 200 volts. These tubes, the 42KN6 is max at 250 volts. I would suggest not going much over 200. 2 1/4 might be getting close to it. The reason for that is if you have any kind of wiring issues to where you have length of wires and stuff that's not quite correct, and shielding, you know, until you learn how to keep RF away from other wiring, you may have a problem with the tube trying to oscillate. So 200 watts or 200 volts is a safe voltage. Even 150 volts would be fine when you're beginning. Until you really get the thing closed up in a box, I would suggest staying well under 250 volts. I think I'm running that with I think there's actually only about 180, 190 volts. I haven't actually measured it. I need to get a meter that's RF insensitive. When I key this up, my little Harbor Freight meter just goes nuts. It just blanks and goes weird numbers on the screen. So I can't measure that voltage with RF present at the present time. Okay, the output circuit Pi network is pretty much the same. I don't have the values on the schematic yet. I will pull everything apart and measure those caps. We're still at the 12 turns, half-inch diameter on the tank coil right there. I haven't changed that. You can see the load cap is a slightly different position now. It may be getting to where I can take the patter, the 100 picofarad patter cap off. It would probably correct that. But the tune, the plate cap, is about half mesh, so it hasn't changed much at all. Key and circuit's the same, except, like I say, I've just paralleled it, added another relay for switching. This capacitor is an RF ground, keeps this 24 volt bias line clean. As I mentioned earlier, this cap is simply a DC blocking cap that keeps our 24 volts from showing up over here on the input coil. We don't need that. The whole idea is for the 24 volts, and it's minus, that's a minus voltage, by the way, or negative. We want the control grid held at negative voltage, for what's called bias. The screen connection has a 0.01 cap to ground, and that again is to keep that at RF ground. We allow it to have a voltage of plus volts on the screen, but we want that to be held at RF ground. So we just put a 0.01 disc cap to ground right there. Parasitic resistor and coil is the same. Probably can't see it, it's hidden down here. This is a 68 ohm with 3 turns of wire wrapped around it. And that's what that PC1 is all about. Refers to as a parasitic choke. Keeps the tube from oscillating at VHF frequencies. You would have no way of knowing it, and it would, cause TVI and all kinds of stuff if this parasitic choke wasn't there. I think that's about it. The only odd thing here is I didn't change my key and circuit at all, but I did have to raise it off of ground so that I could use my negative volts to feed the grid. And so basically this circuit, I just swapped it. It's positive ground now. That's why the coils, normally I had positive voltage coming to the top end of the coil for the collector, but this way I didn't have to change to a PNP transistor and do a bunch of changing on my voltage doubler for the key and circuit. I just lifted the emitter off of ground, put a 0.01 cap to ground there, supplied the negative voltage to that through a standby operate switch, and then fed B plus to ground, and that makes everything stay working correctly. And that way I didn't have to come up with a separate 24 volt supply to feed bias. I'll have this schematic notated with all the values later on this week if you are interested in getting the schematic. The power supply I've covered in earlier videos. Look at the ones that says working with transformers or working with power supplies, and you can kind of get an idea on how to build your power supply up. And I've even mentioned some sources of where you can find some inexpensive transformers. So if you have questions you'd like to ask me about, working toward any specific tube you want to put into a linear, let me know. Send me an email and I will send you the schematics. They're in JPEG form. Make sure you can see that in the, there we go. The schematics are in JPEG form. They're small. Most of them are around 80, 90K, and I can just email them to you. So, till the next video, thank you for watching, and leave a comment if you have any specific tube you'd like to see. If I have something like that in stock, I'll try to do a video on it. And from here, we'll probably go to a little bit larger tubes. It'll be a little while. Summer's coming here, so I'm going to be busy in another work related. I do firewood cutting in the summer, so my time may be limited until fall. But at least this will give you maybe enough ideas and direction to where you can try a couple of these small singular. You could actually put 2 of these tubes together in parallel just fine. Everything would work. You're going to get some changes on the coil. You're going to have to, it'll use fewer turns on the input and your tank. But I can guide you through that whenever you get to that point. Okay, thank you for watching, and we'll see you in the next video.